Everything we do in this video, you're going to want to compare against previous video, the instantaneous velocity and instantaneous speed video. We'll be following a very similar procedure. If you want to find the average acceleration between two events, say that event and that event on a velocity versus time curve, average acceleration between this moment, t1, and this moment, t2, you know that you would draw a line connecting those two events. Yeah, it's a pretty good straight line. With time interval in between them, there's your delta t. You would draw a line connecting those two events, and you would measure the slope of that line. And the slope of that line would tell you the average acceleration between these two events. We want to look at what happens when you bring these two events closer together. So what if we looked at this event right here and this event right here? Let's bring those two moments in time closer together. Let's shrink that time interval. So now we've got this smaller time interval right there, delta t. And if I want the average acceleration between those two events, I would connect them with that line. I would measure the slope, the rise over the run of that line, and get the average acceleration. This would be a negative average acceleration, so would this. Which one of these two would be a greater average acceleration? Yep, it's this one. This one is steeper. This would be a larger average acceleration between those two events, large negative average acceleration. All right, and I could continue to shrink that time interval, bring these two events closer and closer until they met, until I reached a single moment right here. I'll call it t naught. That'll zero. We should say naught. Bring those two events closer together, and the line connecting them becomes what we call the tangent line, the line that just touches the graph at that one moment. And with this tangent line, we can use it to determine what we call the instantaneous acceleration. We usually drop the word instantaneous and just say acceleration, the acceleration of that object at that one moment in time. And we can figure it out by measuring, of course, the slope of that tangent line on our velocity versus time graph. So our tangent line that just barely touches the graph at that one point right there, we can look at its slope. I'm going to extend the tangent line a little farther in each direction. And I can look at its rise right here and its run right there. That's the delta v, and there to there is our delta t. There's our time interval. There's our delta v. And from looking at the graph, assuming a scale here, we can see that our change in velocity is -6 meters per second, and our change in time is 4 seconds between these two arbitrary points that we picked on our tangent line. We can pick any 2 points on the tangent line to use to measure the slope of that tangent line. It comes out to -1.5 meters per second squared. Meters per second gives us meters per second squared. So our tangent line has a negative slope here, meaning at this instant, our object has a negative acceleration. Its velocity is becoming more negative. And we see that. This curve shows that our velocity is going from a positive velocity to a less positive velocity. It's moving in the negative direction. Our velocity is becoming more negative. Oh, forgot to show you that. There's our calculation. Delta v over delta t of the tangent line, -6 over 4 gives us -1.5 meters per second squared. Okay, negative slope, negative acceleration of our at that moment. All right, let's look at this graph here, another velocity versus time graph with some events pointed out on it. I want you to first sketch out this graph and draw in your tangent line at each of these events. Practice drawing in the tangent line. And then once you've got that, use it to answer these questions. At which of these events, at which of these moments is the acceleration 0? And then at which moments does the object, or is the object slowing down with a negative acceleration? And so forth. Okay, so looking for at which individual moments each of these is true. Got a good look at the graph? Got a good look at the questions? Okay, pause the video, answer those. All right, here we go. Answers are at events C, G, and I, our tangent line is horizontal. Horizontal tangent line means a slope of 0, 0 acceleration at those events. Here, at every time we have 0 acceleration, our acceleration is changing from positive over here to negative right here. So in between a positive acceleration and a negative acceleration, it has to be 0 for a moment. Between a negative and a positive, it's 0 for a moment. And here we see our acceleration is approaching 0. Okay, at D, we are slowing down. The velocity is approaching 0 with a negative acceleration, negative slope. At event E, H here, we're also slowing down. H, we're slowing down, approaching 0, but with a positive acceleration. The velocity is becoming less negative. At event F here, we are speeding up. The velocity is getting more negative with a negative acceleration. Negative acceleration, we're getting more negative, speeding up. And then at events A and B, we have an object speeding up. The velocity is getting more positive. And A, our tangent line there, is also a positive slope. Positive slope there, and the object is moving away from 0 velocity. It's speeding up. All right. E was not the answer to any of those, but I do have 3 more questions. At which moments or events is the object at rest with 0 acceleration, at rest with positive acceleration, and at rest with negative acceleration? Ponder that. Pause the video. Answers are I, A, and E. Let's look at each of those. If we're at rest, what that means is the velocity is 0. 0 velocity means not moving forward, not moving backward. We're at rest. So these 3 events here are the moments when the object is, at least for 1 instant, at rest. At event I here, the object is at rest, and the tangent line has a slope of 0. So the acceleration is 0, and the velocity is 0 right there. At event A, the velocity is 0, so we're at rest for a moment. We're not moving yet. You see that it's about to move, and its velocity is about to become positive, which means its acceleration is positive. We see that positive slope of the tangent line. So at rest for a moment, but about to speed up, about to become positive. So that's at rest with a positive acceleration. And here at E, our tangent line, at a point like this, it can be kind of hard to draw in the tangent line, but just imagine taking 2 points around it and draw the line connecting them. And bring those 2 points together, draw the line connecting them. Bring those 2 points closer together, draw the line connecting them, and that'll give you a sense of what the tangent line should look like right there. It's almost on top of the curve itself. So there's our tangent line. And we see that although the object is at rest for this moment, its acceleration is negative. The object has a positive velocity up here, then it has a negative velocity down here. So it's moving forward, then down here it's moving backwards, but for a moment in between it's at rest. At this exact moment, event E, it's not moving forward or backward. So it's at rest right there. But it's about to move backwards. It's about to start moving backwards, which means its velocity is about to change, and a changing velocity is the acceleration. Acceleration is negative because it's about to become a negative velocity.